Okay, in this video we're going to look at playing with these notebooks. Very basic playing to begin with, and we're going to use the Colab notebook. It's exactly the same in Anaconda. Few very minor style differences, and I'll jump across to show you those where they occur. Okay, let's get started. Okay, so here we have our notebook. The first thing we'll probably want to do is rename the notebook. So at the moment it's called Untitled 0, and we probably want something a bit more memorable. So we just click on that and rename it something like Playground, as we're going to be playing with stuff. Hit return and it's now renamed. You can go to Google Drive, and here you will see all your notebooks, including the new Playground. The .ipynb means ipynotebook. If you're doing this in Anaconda, you've got your notebook here, and you can right-click on the top to rename the notebook, and it will show you down here what it's called and where it's appeared. Now you can create new cells by clicking on Code or Text. Let's create a text cell, and we can write text. Let's give it a title. Okay, so you're seeing on the left what you've typed. This is typed in a language called Markdown, which is fairly self-explanatory, and on the right what it's going to look like. To finalize it, for all the cells, use Shift plus Return simultaneously. This will run a code cell and will turn a text cell into some text. Your overall notebook is going to be a mix of text and data. So we've got some text there. We can get rid of that top one by clicking on the bin over here. In Anaconda, you can set the type to Markdown for text or code. And once again, you can just type stuff in here, press Shift-Enter to run the cell. So let's start off by using it as a calculator. What we can do is define some variables. Now a variable is going to be a space in the computer memory where we store something. So we can have, let's say, A equals 4.56 and B equals 5.67. That's defined two variables. We now press Shift-Enter to run that cell. You'll see there's a spinning wheel for a moment while it runs, and then it's finished running. In Anaconda Python, if you have something like A equals 4.5, B equals 3.4, Shift-Enter again, and when a number here appears, you know it's finished running. And we can now print out what we've got. We can start doing some arithmetic, so we can print A plus B, for example. So this is a print command, open and shut round brackets, and then what you want to print inside, Shift-Enter to run it, and it gives you 10.23. You can always check what your variables are by clicking on this little X on the side here. And that will tell you all the variables. And you can click on them and find out what the current value is. We could change things. For example, we can make A equals A plus 3. What this means is you take what the current value of A is, add 3 to it, and put that back into the memory cell called A. So now if we look over here, we'll see A has now gone up to the value of 7.56, and indeed if we print A, it's now 7.56. Now we're probably going to want to do some maths. Basic maths is built into Python. You can see we've used plus here, and we can use minus. To do multiplication, we use the star. So we can print A times B, and that means A multiplied by B. If you want to raise something to a power, we could do something like print A. Now to the power of is star star something, so that's A squared. It's not a little upward caret. That's a common mistake people make here. We've just done addition, multiplication, simple things. If we want to do some more complicated maths, we're going to have to add on to Python's default capabilities. And this is something you do all the time with languages like Python. We will import a library, in this case the math library. So we just type import math, shift enter, let it chug for a while, and it's now imported it, and this gives us a huge number of mathematical functions. So for example, we could work out the square root. So you type math.square root, 16, shift enter. So you see we're typing the name of the package and then the name of dot, then the name of the program from within the package. So this means go to the math package and find the square root function. And it got the right answer. It has constants like math.pi, shift enter, to save you remembering it to too many decimal places, and does trigonometry, math.sine, math.pi over 2. And you can do exponentials, math.exp, say 2.3. Or alternatively, you can do math.e to the power, which is 2 stars, remember, of 2.3, and you'll get the same answer.